Alternative multiplication algorithms, Hindu, which is a left to right algorithm. Let's take a look at 57 times 18. So we start upper left, so 50 times 10 is going to be 500. And we usually just put the 5 in the right column for its place value, so the hundreds column would be over here. You could put the zeros if you want, but I don't usually. Then we move on to 50 times 8. Well, 5 times 8 is 40, so 50 times 8 would be a 400, and 400 bumps that 500 up to a 900. We're done with the 50, so we move on to the 7. 7 times 10 is 70. No problem. 7 times 8 is 56. This is interesting. So the 6 ones goes here. The 50 bumps the 70 up to 120. The 100 bumps the 9 up to a 10. So the answer is 1026. So Hindu left to right. Let's try it again for a 3-digit times a 2-digit. So how about 235 times 42? So we'll start with the 200 times the 4. 2 times 4 is 8, 100, and then a 10 would be 1,000. So 8,000 is what we get. So here's the hundreds, and then you could put 3 zeros there if you like. Usually we just place it in the right column. So again, 200 times 40 is going to give us 8,000. And then we have 200 times 2, which is going to be 400, so we just put the 4 in the hundreds column. Done with the 2 at the top, the 200, we move on to the 30. So 30 times 40, well, 3 times 4 is 12, 2 zeros is 100, so that's going to be 1,200, and that's going to bump both of these. So the 1,200, so that's 1,200, the 200 bumps the 400 to a 600, and the 1,000 bumps the 8 to a 9,000. And then 30 times 2 would be 60, and so the 60 just goes into its column. Done with the 30, move on to the 5. 5 times 40, 5 times 4 is 20, but it's 40, so it'd be 200, so we're going to have to bump up the 600 to an 800. And then 5 times 2 is 10, so that's 0 ones, and the 10 bumps that 60 up to a 70, so the answer should be 9,870. And again, that's the Hindu left to right, starting at the top, moving across and down. Hope that was informative. Take care.